Hello guys, so in this video here I'm going to be talking about converting decimal numbers to binary numbers in C. But before we get there, we need to go through some basic math and some concepts. So first thing, to go from a decimal number, right? So base 10 to base 2, right? I'll just put it like that. If you have the number, let's say 21, and you want to convert it from base 10 to base 2, what you do is the following. You take the number and you divide it by 2. Alright? So 21 divided by 2, you're going to get 10, 2's 20 with a remainder of 1. Now this here is your new number, 10. So 10 divided by 2, you get 5 with a remainder of 0. Then 5 divided by 2, you get 2, right? With a remainder of 1. Now 2 divided by 2, you get 1 with a remainder of 0. Then 1 divided by 2, you get 0 with a remainder of 1. So what I'm saying here is that these numbers that I have here, right? Let me just highlight that. This here is n. This is your first iteration of n. This becomes n again here, right? This is n. I'm just putting an annotation here, right? And this is n. So what we're doing effectively is we're saying n divided by 2, which is base 2 we're converting to, and we're getting a new n. So how we can represent that in maths? We can say new n, right? So n new is equals to n original divided by 2, right? So the general case, the n here, it's all n. So it's like saying n, the new n is equals to the original n divided by 2. So that's how we generate these n. Now, when you have n equal, n should be greater than 0. All right. So when n is when n is equal to 0, you stop there. All right. And all these remainders you have here formulates a binary number. So what this means that this will be the most significant bit of the binary number, and this will be the least significant bit. All right. So now you have like 1 0 1 0 1. Okay. So let's see, what is this? 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. So this is like 16 and 4 20 and 1 21. Okay. So we got a concept here that we should, how we generate the n. Now what about the remainder? The idea in getting a binary number is utilizing these remainder values and taking the most significant bit, which is the last remainder, and the least significant bit, right? And creating that binary number. Now, if you can store these remainders, right, in an array, then the last element you store in the array needs to become the first element that you would print. And you can do that using just a loop, right? Writing a for loop to do that. So let's look at it from this standpoint. Let me just get this color right. So to the remainder, there is this concept called modulo. So A modulo B means that you're dividing A divided by B. And if you have a remainder, right, that is the modulo, right? Whatever is the remainder in this division. So what I mean by that, 5 modulo 2, what is the answer? So 5 divided by 2 is 2, but there's a remainder of 1, so it's 1. So let's say 6 modulo 4. The remainder here is 2, right? 12 modulo 5. Again, here you get 10 and a remainder of 2, right? So A modulo B gives you whatever is the remainder, that is what is stored here. So we know how to generate the new n, and we know what is modulo, right? And we know that the modulo, the last modulo value we have, right, is the most significant bit, and the first one is the least significant bit. Now we need to find a way to store this in an array. All right, so how are we going to store these numbers in an array? Let's think about it. Every time you have you can write something like this. Let's just think about a simple idea here now. Now bear with me here, guys, right? Don't have, you know, other methods to erase the board here, but I'm just trying, okay? So let's go. So if you have, let's say we want to store the numbers in an array, maybe we can have a loop. So let's say our number is well, we know we're dealing with array will have elements a of I, right? Will have I elements. So what I mean by that, if you have a of 4, it means you would have 4 elements like 5, 10, 15, 20. But this here is a of 0. This is a of 1, right? A of 2, and this is a of 3. All right. So I think we need to be careful how we write this, because here I have a of 4, right? So this is the size of the array, right? But when I write it here, a of 0, a of 1, these are the indexes of the array. And like a of 0 here is actually equals to 5. A of 1 is equals to 10, right? So we get that concept going. Now, how can we take a base 10 number and write a code in C, right, to show its equivalency in base number 2? So we know all this stuff here now. So how do we go about doing this? We know what is modulo, we know what is n. So we go again. We have this number. Let's take this number 25, right? We divide by 2 and we get 25 divided by 2 is 12. We have a remainder of 1. We divide this number again by 2. 12 divided by 2 is 6. We have a remainder of 0. We divide again by 2. We got 3. We have a remainder of 0. When we divide 3 by 2, we have 1, right? And the remainder is 1. Now we divide 1 by 2, we have 0, a remainder of 1. Now we stop here. So these are all values here, right, of n. This is n, 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 n. So to move from the first n to the second n, what we're doing here is n is equals to n upon 2, right? But every time we do this, until we will stop, until, right, until n is, we do this on so long that n is greater than 0. So in this case here, n is equal to 0, so we stop the operations here. So in a for loop, we must have this condition, n must be greater than 0 to execute this condition. Now we want to keep the value here gonna be, this is gonna be the most significant bit, this is gonna be the least significant bit. We can capture this in an array. So here we start with, we're gonna get like 25 modulo 2, we have 1, that is this R1, right? Then we're gonna have 12 modulo 2, we're gonna have giving you that 0 there, so this gives us a 1. Then we have 6 modulo 2, right? 6 modulo 2 here, we're gonna have an x 0, right? Then 3 modulo 2, this will give us a 1. Then we're left with pretty much 2, 3 modulo 2 gives us a 1, and then 1 modulo 2, right? This will give us a 1, right? Pretty much the remainder of these operations. So what you're seeing here, we need to find a way to put all of this in code now. So we want to get a remainder, and we want to put the remainders in an array. All right. So how do we do that? So first thing we do, we have to know, we have to ask the user, or we can state what is the number we want to convert, right? So whatever is the number, you can write scanf to say, printf to say, please enter the number. Let's try to do that. So here we go. We say here, printf, right? Enter number, right? And then we scanf that, scanf, right? Percentage D. So let's say the number is defined as n. So you get n here, right? Though we need to, what are we doing with this n? We want to loop it through some iteration. So we would say, right, for I is equals to, well, we have to say int I, right? Int of I, right? Declare a counter here. So for I is equals to 0, first iteration, right? The condition is that n must be greater than 0, and every time we go through the loop, we will increment the counter, right? So let's see how we do that. So what's the first thing we do? We take the number n, right? And we do a modulo on it. So n modulo 2, and we store the results in a variable r. So maybe here we should have an int of r, right? So we store it here. So the first time with the 25 divided by 2, you get 12, but the remainder is 1. So this 1 is going to go into r, right? So we need this. and we need a new n. To get a new n, we take n, we divide it by 2, and it's equals to n. So we get a new n. What else do we need to do? We need to take this I and put it in an array, right? So we can say that A of I is equals to R, right? And we close this loop. So what we are doing here, when we do this operation, we get R, we take R and put it in this array. So let's say when I is 0, the first value is going to be stored in the array. Then I becomes, so n would start as 25, operate on it, we have an I, we store it. Then n becomes 12 here, so we're gonna iterate this loop. And then we need to print this array out, right? Print array. So the array would have I elements, right? A of I. Now to print it out, let's say I is equals to 5. We want to print it backward, like from the back. So we can say j is equals to I minus 1. J must be, we're going up to the 0th term, so j must be greater than or equal to 0 and decrement j, right? So we'll look how to do that now. I think you're getting it. Oh, this is hard to do. I should just get a new screen. Like, all right. So to print the array, if you have this array, A of 4 equals to, let's see, 5, 10, 15, 20. Now you want to print it in this order. You want to have 20, right? 20, 15, 10, 5. Well, we're dealing with bits here, right? So we will have like zeros and ones. So what if I write it like this? A of 4, right, is equals to 1, 0, 1, 1. So our ideal print would be, when we print this out, we want to get 1, 1, 0, 1. All right, this should become most significant bit. So how do we reverse this array? To reverse this array, we use a loop like this. We say that int of j is equals to, what is, this is I, right? I minus 1. All right, so this for our loop here. Now for I minus 1, that's going to be the starting point here, right? And j must be greater than or equal to 0, right? And then we decrement j, right? So now we'll put in this here, print f, right? Percentage d, right? A of I, right? I think that's making sense. So what we're doing here, we are moving, let us say this is ICE4. So we're gonna be printing A of 3 first, followed by A of 2, A of 1, A of 0. All right. So guys, I give you all the concepts here, and now I will show you the bareback code, how this is run. Of course, I have added some more um, subs to the code so that you can figure out the rest here. Here's my code. I explain all of this here. I explain this here, right? Um, think I made a blunder here. I said A of I. This should be A of J. Okay, because we're running this array now based on J, not I. Okay, so back to the code. So the first part here, what I try to do is to print multiple decimal values. I want to give you a chance to enter, let's say 5 or 10 values. You have an option to set how many decimal numbers you want to enter. So this part here is simple, right? And I just wrapped this printf scanf here, where you're entering the decimal number in a while loop. So I'm just saying, while you state how many numbers you want is greater than 0, run this operation, then decrement this loop, and the actual operation you run, you're calling this function dec to bin here. So let's look at that part. Dec to bin means that you're passing in n, whatever is n, into this function here, and n should be greater than 0. Then you're doing this mathematical operation here, getting the values stored in this array, and then you're printing this array. So let's run this code and you're going to see what I'm talking about. All right, so let's go for it. So run. So it says enter the number of decimal numbers to convert to binary. Let's say I want to look at 8 decimal numbers. Let's say my first number I want to convert to binary is 1. So I hit 1. Next, enter 2, 3, 4, 5, 6, 7, 8. All right. So this is how you can look at multiple numbers on a screen here now. Now, if you don't want all of this, what you can do, I can show you how you can just make some changes to the code if you just want. So what you could do here, you don't need to have this portion, right? And you don't need this, right? You don't need this. You don't need this, right? And this line here and this. So you're gonna start with this bracket. You're gonna end with this. You're gonna call this function, and that's your operation. That will just give you one number. All right. So guys, I hope I get it through. It'd be nice if you guys can subscribe to my channel, going forward, because I'll continue to put out content, and I want the channel to grow. All right. So this is all for now. Bye.